Welcome to the video lecture. In this video, we are going to see about K nearest neighbor algorithm. So K nearest neighbor, which is a KNN algorithm, it is a supervised machine learning method which is used for solving both classification and regression problems. It is used to handle both numerical and categorical data. The first step is finding the K, the main idea is finding the K nearest neighbors for the given data point based on a distance metric. The distance metric mostly used here is Euclidean distance. There are also other metrics available which can be used by the KNN algorithm. And the class or value of the data point is then determined by the voting or taking average of the K neighbors. KNN is very less sensitive to outliers compared to other algorithms. And this is a graph we are having for KNN. So in this graph, these data points belong to one category and these data points belongs to another category. And if you are introducing a new data point, we have to find whether this data point belongs to category 1 or category 2. So by using KNN, we are going to find the distance between the data points, the pre-existing data point and the newly introduced data point. The data point which is having shortest distance is the group of the data point which is having the shortest distance to which the newly data point belongs. So if this data point is having shortest distance with the newly introduced data points compared to these data point, then this data point belongs to the category 1. So this is the logic behind the KNN algorithm. So distance metrics used in KNN algorithm is the Euclidean distance, as I already told, and there are other metrics which are used in KNN algorithm. They are Manhattan distance and Minkowski distance. So Euclidean distance is the Cartesian distance between the two data points which are in the plane. So choosing the value of K for the KNN algorithm, the value of K should be chosen based on the input data. If the input data has more outliers or noise, a higher value of K would be better. And it is always recommended to choose an odd value of K so that we can avoid ties while classifying the data point. For example, if you are choosing K value as 4, then while in the final output, if two of the value of K belongs to one group and the 2 of the data K value belongs to another group, then it will be resulting in a tie. So it is always recommended to choose an odd value of K, and the value of K, to choose the best value of K, we are always using a cross validation method, which is another technique which helps in selecting the best K value for the given data set. So the working of KNN algorithm consists of these 4 steps: finding the optimal value of K and then calculate the distance between the data points, and finding the nearest neighbor by giving ranks to the shortest distance. And then the final step is for classification task, we are going for voting, and for regression task, we go for taking average. So next we are going to see a problem for classification task based on using KNN algorithm. So this is a given data set which is having sepal length and sepal width and the species to which it belongs. So we are going to find the species of the newly introduced data point of sepal length and sepal width. So for these newly introduced data points, we are going to find the species using KNN classifier method. So the first step is finding the distance between the data points. So the formula for finding the distance is square root of x minus a square plus y minus b square. Here x and y represents the newly introduced data point, and x and y represents the newly introduced data point, and a and b represents the pre-existing value of the data point. So the first row, it is calculated here. The distance between the newly introduced data point and the first row consists of pre-existing data point is 0.608. That is, by applying in the equation, we get the value as 0.608. Likewise, we have to find the all other values for all the rows are present in the given data set. So this is the distance calculated for the given data set for the newly introduced data points. So the next step is finding the rank based on the shortest distance. So here the shortest distance is 0.22. So it is ranked as 1. Likewise, you have to find the next shortest distance, which is 0.36, which is ranked as 2. Likewise, we have to rank all the values based on the shortest distance we have calculated in the previous step. So the next step is choosing the value of k, finding the nearest neighbor. So here, if I'm choosing the value of k as 1, the value of k belongs to rank. So the species belongs to rank 1 is Setosa. So if I'm taking k is equal to 1, then it belongs to the species Setosa. And if I'm taking k is equal to 2, I have to find the value of k is equal to 1 and k is equal to 2. So both the values belong to Setosa. If I'm taking k is equal to 3, so these two belongs to Setosa and 3 also belongs to Setosa. If I'm taking k is equal to 4 and the first 1, 2, 3 belongs to Setosa and fourth one belongs to versicolor. So out of 4, 3 belongs to Setosa and 1 is versicolor. So we are going for voting. Based on voting, the species is Setosa. Species can be chosen as Setosa. So if I'm taking k is equal to 5, I have to consider all the values of k, 1, 2, 3, 4, 5. So for first 3 values of k, it belongs to Setosa, and fourth value of k, it belongs to versicolor, and for fifth value, it belongs to virginica. So out of 5, there are 3 Setosa, 1 versicolor and 1 virginica. So based on voting, the species for the newly introduced data point is Setosa. So other than that, you can also choose the value of k as 7. Since there are more than 10 values here in the original data set, we can also go for k is equal to 7. So here in k is equal to 7, k is equal to 6 belongs to Setosa and k is equal to 7 belongs to versicolor. So out of 7, there are 4 Setosa, 1 virginica and 2 versicolor. So the voting choose the Setosa species again. So for the newly introduced data point belongs to the species Setosa using KNN classifier problem. So this is the way of finding the species for the newly introduced data using KNN classifier problem. So next we are going to find the value for a newly introduced data point using regression task. It includes numerical values. So this is a data set given which consists of height, age and weight, and we are going to find the weight of the newly introduced data points 5.8 and 337. So using the same logic, we are going to find the distance for the newly introduced data point to the pre-existing data points. So for first row, the distance can be calculated as square root of 5.8 minus 6 whole square plus 37 minus 40 whole square, which is equal to 3.007. So likewise, we have to calculate the distance between the new data points with the old data points, and we have to write over here. So the calculated distance are listed here, and then the next step is finding the rank. So based on the distance calculated, we have to assign the rank, which is assign the rank for the data which is having shortest distance. So the first rank is can be assigned to the shortest distance in the given data set. So this is the shortest distance for the data points, and it is assigned as rank 1. And since in this data set there are 2 values which is having the same distance, so I am ranking both the values as both the distance as 2. Likewise we can rank till 7. Since I'm giving 2 for 2 values, I skip the third rank and move on to the fourth rank. Likewise, I have given rank based on the shortest distance calculated. So here the first step is finding the distance, and the second step is assigning the rank, and the next step is finding the, based on k value, we have to find the weight of the weight for the given new data points. So I'm taking, since there are 7 values in the given data set, I'm choosing the k value as 3. So for taking k is equal to 3, I have to take the average of the weight belongs to the respective rank. So the first rank is 80, is having weight as 80, and the second rank is having weight as 78. Since there are 2 values for second rank, I'm choosing weight as 60. So I'm taking the average 60 plus 78 plus 80 divided by 3. So the new weight calculated for the newly introduced data point is 72.6. So this is how we have to calculate the value for the newly introduced data point using regression task in KNN, using KNN algorithm. So these are the 2 ways of solving classification and regression task using k nearest neighbor technique. So thank you for watching the video.